Hello, everybody. Welcome back. Now we are going to go over the garage door exercise 2. Um, so this is just going to build off of the first exercise 1, right? The first one. So let's go ahead and let's read through what the customer is asking for, and we will build the program going off of that. So let's see here in this exercise. We want you to apply your knowledge of relay logic instructions to design a program which will maintain the appropriate door movement once initiated by the operator. The opening or closing operation of the door will continue to completion even if the operator releases a push button which initiated the movement. The program will adhere to the following criteria. Door movement will halt immediately when the stop switch is initially pressed and will remain halted if the switch is released. Okay. Pressing the open switch will cause the door to open if not already fully open. The opening operation will continue to completion even if the switch is released. Vice versa with the close. Pressing the close switch will cause the door to close if not already fully shut. Closing operation will continue to completion even if the switch is released. Okay, so let's stop real quick. So basically the difference here is it's not going to be momentary, right? So we need to do the seal in and we need to incorporate the stop switch. Simple enough, pretty straightforward. If the door is already fully open, pressing the open will not energize. If the door is fully closed, close switch will not energize the motor. Same as before. So we shouldn't have to change any code there. Under no circumstances will both motor winders be energized at the same time. Same thing with the code. Don't have to do anything there. The jar lamp will be illuminated if the door is not in either fully closed or fully open position. Same, nothing new there. The open lamp will be illuminated when door is in the fully open position. Same, shut lamp will be illuminated if the door is in the fully closed position. Same thing there, nothing new. So it's your responsibility to lower the latches and keep rungs to a minimum as before. Ensure that you have made effective use of both instructions. So comments and bit descriptions. So nothing really new except for the motor control, right? With the push buttons. So instead of it being where the operator has to continuously hold the button in, it is now a momentary push until it either hits the switch or we hit stop. So let's dive on in to our code and see what we got to do to change it. So let's see, motor control. So we are going to be looking at this rung, or come on. It's still on run. So this rung and this rung, everything else should be the same. So rung 0 and 1. All right. So, let's see. So we're going to do a seal in, right? So with the seal in, we do our branch, which is the same as, an or statement, right? This or that, or if you're familiar with line diagrams, it would be a parallel circuit, right? So nothing really new, just a new platform that we're doing this stuff on. So we'll paste that and motor up, and let's see, and then we have to add in our stop bit. So let's see, and our stop bit is a normally closed bit. So let's go ahead and copy this guy and paste this guy to the right. Let's move him over here. I'm a big fan of keeping the bits, like if it's, similar, bits being used, rungs as they go down, like let's keep them in the same order. That's just how I like to see things. You do think that you want to do it? In my opinion, it is just a form of like structuredness or organization. But yeah, I don't think it's the best practice, but it's pretty darn good practice in my opinion. So there's our stop bit. And so really all we did is we just added a bit, a permissive in here, or an instruction bit of, once the motor starts, keep going until the stop button's pushed. Not too difficult, man. So let's do that same thing over here. Let's copy our bit there, and it's right. There we go, stop bit. And oh, I'm sorry, did the wrong one. So let's go open button and go there. And if we go copy and paste, bring that down. And then if we copy our name or bit name, then boom, goes the dynamite. That's all there is to it. Let's go ahead and test this out. Make sure we got this right and open. Oh, it probably works better when you put it in run, the PLC back in run mode. So open is not opening. Why? Oh, because my stop bit isn't correct. So you can see here, my stop is not, it's not satisfied. And why is that? Because I have examined when open. And so basically it would be, this would be satisfied or active or true if this was a normally open push button, but it is not. It's a normally closed. So I used the wrong instruction. So let's try this again. And open we go, stop, open we go. So that's working good, just like that. All right, and then close, stop, close, perfect. Now, what happens when it's going one direction and you hit the other direction? Oh, it jumps the other way. Interesting. They didn't say anything about that. Now, in the real world, you wouldn't want that because it would jar, right? It would jar your, it's going to like slam your motor, right? Because it's going one direction, all of a sudden it's just going to slam it the other direction. The motor itself, probably not, well, actually it could create a bit of eddy currents, which would be basically where you're backfeeding electricity down your wire. So instead of your electricity coming towards you, it could slam it, some current back. Wouldn't be too much, but again, this is a little motor. It's a much different story when you're working with gigantic motors, like 100 horsepower, a couple 100 horsepower motors. Things become a lot different, and you have to be a lot more sensitive to possibilities like that. But where it would create issues is on your coupling, where your electric motor and your garage door movement come together, whether it be a chain or if it's like a chain drive, like on your bicycle, or if it's more of a direct coupler where it's literally like two things going like this and they're going together, right, to turn. Well, if the motor is going this way and then all of a sudden it slams the other way, well, this still, the garage door still has the momentum of the direction one, and the motor slams into direction two. And when you got momentum going there, then boom, you're applying forces on that coupler, and probably it's going to be bad for that coupling point, and eventually, with time, that will break, and that will have to be replaced. And it probably won't be the first time that happens, or even the first 1,000 times that it happens, but it will happen eventually. And chances are high that that it would happen in real life. So those are things that you would want to think of. Customers not asking for a change or for us to be aware of that. So we're going to let it go for now. Let's go through all the rest of the exercises and see if that ever comes up. If it doesn't, we might do an extra exercise or add on an exercise to figure out how we can prevent that. or not. I don't know. We'll see. We'll see what happens. It's been a bit of a day for me today, so we'll see what kind of attitude I'm in here after a couple more exercises. Okay. Okay. Well, thank you, and we'll see you on the next exercise.